Well, it's just really an honor and it's great to be here. I'm really excited to get to attend the European Lunar Symposium. I've never had this opportunity before, so just really happy to be here. And the first thing I just want to say is I want to echo Greg's point that, this is the idea of getting back to the moon to do science and to do exploration has been a dream for a long time, and we're here. It's happening. And so I'm going to talk to you a little bit about what's going on. As Greg said, I'm as of 2 weeks ago, the acting Deputy Associate Administrator of NASA's Exploration Systems Development Mission Directorate. It's a mouthful, but it is the exploration side of the house. And I'm really excited to be back here in the UK. Greg mentioned that I got my PhD in volcanology. What he didn't say is I got it just down the road in Lancaster. So it's really great to be back in this neck of the woods. I love this part of the world. Really happy to be here. So I only just recently joined Exploration Systems Development Mission Directorate a couple weeks ago, and so I still got a lot to learn, but what I'm finding is just absolutely amazing, and I'm just having a great time being part of this organization. The switch really feels natural to me, bringing the science that we've been doing and the passion that we've had for scientific exploration of the moon and then going on to Mars. This is a great opportunity to bring these two together. Without science, exploration lacks purpose, and without exploration, science is bounded. There's so much we can do when we work together, and why we explore is as important or more important than how. So when we talk about why we explore, NASA is going to explore for 3 reasons. Science, number 1, of course, which is great. National posture and inspiration. And it's really great to see, let's see if we can get the slide here. Is it gonna go, Rick? Oh, there it is. Is that the right one? Yep. So these are the 3 pillars. And as I said, science being the first pillar, and then national posture and inspiration. And these represent all of our stakeholders' values. It's really exciting that science is the first pillar. I think this is critically important. It drives our exploration missions, and the value the discoveries are going to make are just impossible to even calculate when we're looking in advance. The science also fuels our economic development as well as discovery, and the moon is a rich destination for scientific discovery. Studying and analyzing lunar environment and samples from an area of the moon that humans have never visited before is going to help NASA unravel some of the greatest mysteries of our solar system for the benefit of everyone around the world. The second pillar, of course, is national posture. Artemis comprises many international partners, commercial space partners, and other government agencies that together are going to make lunar exploration possible. We've long collaborated, of course, with our European counterparts on incredible projects like the International Space Station, and those partnerships have bolstered our country's reputations on the international stage and have made incredible contributions to humanity's shared knowledge. We're leading by example, building on what we've already achieved in low Earth orbit and bringing others along who share our vision so that we can ensure the next steps that humanity takes will be in peace. Our final pillar is inspiration. I know everybody in this room still remembers when you were a child looking up, maybe at the stars, maybe at the moon, and that we still, if you're like me, still, when I look up at night, get so inspired by looking into the cosmos. The Artemis campaign is inspiring humanity to go further than we ever thought possible, to be curious and push boundaries and achieve the impossible. Together, we're going to build the next generation of space entrepreneurs and STEM workforce, and reminding each other that we are capable of amazing things and things that others only dream about. Artemis will continue to inspire by showing the world that NASA and all of our partners have not only dreamed it, but we are doing it, and we're doing it now. So let's talk a little bit about the Artemis campaign and what this means. The Artemis campaign is, in fact, a series of increasingly complex missions that provide ever-growing capabilities for scientific exploration of the moon. Together with all of our partners, NASA is working towards establishing an infrastructure for long-term exploration in lunar orbit and on the surface. This infrastructure is going to facilitate ongoing scientific research and discovery for the benefit of all humanity. Ultimately, what we build, test, and discover at the moon will determine human capacity to live and work in deep space for longer periods of time, setting us on a steady path for that next giant leap to Mars. So Artemis 1 has already gone. It was our first uncrewed flight test of the Integrated Space Launch System rocket and the Orion spacecraft. Early in November in 2022, we lit up the sky as we lifted off from NASA's Kennedy Space Center in Florida. I hope many of you saw that. It was really spectacular. We flew a 26-day mission around the moon, sending Orion further than any spacecraft designed to carry humans and return them safely to Earth has ever gone before. On December 11th of 2022, Orion splashed down in the Pacific Ocean off the coast of Baja, California, where a cross-government team was waiting to recover the spacecraft and bring it back to the United States for analysis. Since returning the vehicle to dry land, we've removed the scientific payloads inside and inspected the capsule, learning all that we can before we fly astronauts on our next mission. The payloads and instruments on Artemis 1 reflected contributions from across NASA, as well as 5 international partners, and partnerships among several universities, industry partners, and other research institutions, including the European Space Agency. The mission taught us a lot about how to integrate these payloads with our deep space transportation systems, and that knowledge is going to help make sure that we take full advantage of every opportunity on future Artemis missions. The lessons learned from these payloads are going to help us gain better insight into how best to conduct science with Artemis. And now we're getting ready for Artemis 2. Since the successful flight of Artemis 1, the agency has been diligently implementing what we've learned in preparation for Artemis 2, where we're going to fly NASA's Reid Wiseman, Victor Glover, and Christina Cook, and the Canadian Space Agency's Jeremy Hansen, flying them to the moon. Artemis 2 is now planned for September of 2025. It will be a 10-day lunar flyby mission that will test the Orion spacecraft's life support systems to prove the capabilities required for crew to thrive in deep space. As we prepare to fly, safety is and will continue to be our top priority. And this is something we are pushing pretty strongly, is that we will fly when we're ready and when it's safe to fly our friends and bring them back safely. So I'll tell you, as I said, this is getting really real. Just a couple weeks ago, in just my first couple days on the job, I went down to Kennedy Space Center and I got to see a lot of real hardware for Artemis 2. It was really, really comes home for someone as a scientist thinking about where we're going. I got to see the mobile launcher preparations. I got to go out to the pad. I got to see the work that's going on the emergency egress system. There's some repairs that are being made and some new design changes to make sure that our astronauts are safe when they fly. I got to see the Orion crew modules for Artemis 2, Artemis 3, and Artemis 4. There is hardware down there at Kennedy Space Center already for all 3 of those Orion modules, crew modules. Pretty spectacular. I got to see and hear about some of the heat shield analysis. You've probably heard that as the Artemis 1 heat shield was coming back in, the Orion capsule was re-entering Earth's atmosphere, the thermal protection system on the bottom experienced charring, which you want, that's supposed to happen. But some of that material also came off. There was some unexpected damage to that thermal protection system. So we're looking really closely at that damage and trying to best understand what happened and how we can mitigate that for Artemis 2. And as I said, to reiterate, we will not fly our astronauts until we know that we can bring them safely back. So Artemis 2 will also include science, of course. The Artemis 2 will provide opportunities to conduct science and human research. The Artemis Research and Crew Health and Readiness, or ARCHER, will be worn by crew members to collect data on sleep-wake patterns, activity levels, and performance of operational tasks. A second study called the Immune Biomarkers will examine samples of the crew's saliva to determine how space travel affects the immune system. We're also excited for the opportunity to have humans make observations from the cislunar vicinity and lunar far side for the first time in over 50 years. Oh, look at that. I went to the wrong slide, didn't I? What? One ahead. I apologize. Artemis 3, as I said, planned for 2026, will mark humanity's return to the lunar surface in more than 50 years. NASA will make history by sending the first humans, including the first woman, to walk on the moon to explore the region near the South Pole. For Artemis 3, SpaceX is providing the human landing system called Starship that will transport the Artemis 3 astronauts from Orion and lunar orbit to the surface of the moon and back again. The company will fly at least one uncrewed demo mission to land Starship on the lunar surface before it'll be ready for its first Artemis mission. And I hope you all saw just a couple weeks ago, or was it last week? I don't know. It's running really quickly. Starship had a successful flight. Pretty exciting. And before the crew launches on Artemis 3, SpaceX will launch a storage depot into Earth orbit and a series of reusable tankers that will carry propellant to fuel the Starship. The uncrewed Starship human landing system will then launch to Earth orbit and rendezvous with the storage depot to fill its tanks before executing a translunar injection and traveling to the Lunar Narrow Rectilinear Halo Orbit, or NRHO, where it will await the Artemis 3 crew. When both spacecraft have arrived in NRHO, Orion will dock with the Starship, and the two astronauts will board the Starship to head down to the lunar surface, while the other two remain on Orion. During the moonwalks, the astronauts will take pictures and video, retrieve samples, collect other data to meet specific scientific requirements. Axiom Space is providing the Artemis 3 surface suits and spacewalk systems, which will provide enhanced mobility for conducting science. NASA's Planetary Science Division, of which I was a part until 2 weeks ago, recently worked with their human spaceflight colleagues to select the first science instruments for astronauts to deploy on the surface of the moon during Artemis 3. I'm really excited about the packages that have been selected. Once installed near the lunar South Pole, these 3 instruments are going to collect valuable scientific data about the lunar environment, the lunar interior, and how to sustain a long-duration human presence on the moon, which will help prepare NASA to send astronauts to Mars in the future. What we learn from new lunar samples is going to help us understand the makeup of the moon, the Earth, and our solar system, and ultimately contribute to our understanding of how to sustain life beyond our home. Artemis 4 will be our first crewed mission to Gateway, our lunar orbiting space station. 2 modules will already be in place when astronauts arrive: the Power and Propulsion Element, or PPE, and the Habitation Logistics Outpost, or HALO. The Artemis 4 mission will install a second habitation element called the International Habitation Module, or Lunar IHAB. Lunar IHAB is going to be provided by ESA with significant hardware contributions from JAXA. It is one of 4 Gateway modules where astronauts will live and work as they orbit the moon. While 2 Artemis 4 crew members stay on the Gateway to continue setup and conduct research and monitor ground activities, the other pair will enter the Starship human landing system, and disembark to the lunar surface for science and exploration. At that time, for Artemis 4, the larger and more powerful version of the SLS rocket will be used, known as the Block 1B, and the second iteration of the mobile launcher, or Mobile Launcher 2, are also set to debut for this launch. I also got to see some of the hardware for Mobile Launcher 2. Pretty cool. This is really moving along. So we mentioned the Gateway. The first space station in lunar orbit will have already taken shape prior to Artemis 4. Gateway's first 2 modules, the PPE and HALO, will already have launched aboard a SpaceX Falcon Heavy rocket. These elements will take about a year to reach NRHO. They're going to rely on solar electric propulsion and the gravity of Earth, Moon, and Sun to slowly spiral out to their destination. As the powerhouse of the Gateway, PPE is going to generate about 60 kilowatts of electrical power for Gateway subsystems and its solar electric propulsion system to keep the station in orbit around the moon. PPE will also provide capabilities for high-rate communications between the station, lunar surface, and Earth. As you can see in this diagram, Gateway will be very similar to the International Space Station, essentially a hub for science, relying on contributions from partners all over the world. We've already selected some of the initial instruments for Gateway. What we learn from these science experiments and environmental monitors on crewed and uncrewed missions will make long-duration space travel for humans feasible and safe. Our magnetosphere here on Earth protects us from all but the most extreme space weather events. But in space, space weather is a primary risk to human health and mission success as we travel further and further away from Earth. So the instruments that have been selected to focus on radiation monitoring and space weather are going to be critical. We're really proud to be partnering with both ESA and JAXA to help protect our future astronauts. Further exploration of the moon will enable investigations related to our sun, including studies of the historical record of solar activity as preserved in the lunar soil. It will also enhance our ability to understand and predict the sun-induced radiation environment experienced by astronauts exploring the moon, Mars, and beyond. Artemis 5. So Artemis 5 will be NASA's 4th crewed mission under the Artemis campaign. The mission will demonstrate the capabilities of a second human landing system developed by Blue Origin, Blue Origin's Blue Moon lander, and will also incorporate a lunar terrain vehicle. In addition, ESA is going to provide the Esprit refueling model, and the Canadian Space Agency's Canadarm3 robotic arm will also be added to the gateway. Oops, get back. The addition of the lunar terrain vehicle, as you can imagine, is going to greatly improve the range that our astronauts can explore on the lunar surface. This means that we can collect a greater diversity of geologic samples at the moon. This graphic here just shows for the Apollo missions that you can see just an incredible increase in both the volume of samples and the distance to locations where the samples were collected during the Apollo missions when we're able to add the lunar roving capability to the architecture. The Artemis lunar terrain vehicle will have even more capability to gather, transport, and protect our samples, leveraging remote operations to continue working in between the crewed missions. I think that's a pretty spectacular addition to this program, that we can continue doing science in between the crewed missions. Beyond Artemis 5, future missions are going to continue to expand our ability to explore, conduct science, and live and work on the lunar surface. We currently have hardware right now in production for all the missions through Artemis 9. And to me, this was one of the things that when I first came into this is what really makes this real. We're not just talking about going once or twice. We have hardware in production through Artemis 9. Artemis is so much more than just boots on the lunar surface. It's about long-term exploration and utilization of the moon. In April, we were really excited that the US and Japan signed an agreement to advance sustainable human exploration of the moon with the pressurized rover, which is going to further enhance surface mobility beyond the capabilities of the lunar terrain vehicle. The enclosed and pressurized rover will be able to accommodate 2 astronauts on the lunar surface for 30 days and will have a lifespan of about 10 years, enabling it to be used for multiple missions. It can also be operated remotely, again, allowing for positioning it at the next crewed landing site and enabling science research between the crewed missions. I'll talk a little bit about the whole overall architecture and the process and how we got to this, the architecture that we have for Artemis and for the moon to Mars. How did we get to this point? How did we determine what investments we're going to make for this campaign of deep space exploration? And the answer really is in this architecture. This is something I'm learning about every day. I'm getting deeper and deeper into it and trying to absorb as much as I can. But the NASA's Moon to Mars architecture is not a mission. It's not a manifest, and it's not a set of requirements. Instead, it's a blueprint that defines and ties together all of the elements that are needed for long-term human-led exploration and scientific discovery in space. The architecture today consists of 4 segments, and those segments grow in complexity and the potential for discovery as we incorporate lessons that we're going to learn and build up as we build the infrastructure on the moon that will help advance our capabilities and ultimately take us on to Mars. So last November, in November of 2023, we completed our 2nd annual architecture concept review. These yearly internal reviews are going to ensure that we're making the investments needed to achieve all of our Moon and Mars goals, Moon to Mars goals. We also began to define opportunities for new programs and projects that can close some of the capability gaps that are identified by developing this architecture. As part of our architecture concept review process, we're setting the stage right now for initial human missions to Mars as we develop a robust presence in lunar space. Using a systems engineering process, we're identifying the priorities decisions that we need to be making today, that need to be made when developing the first crewed Mars missions. These decisions that are being made today are those that have the most flow down impacts on our Mars architecture or need to be made earlier to allow necessary technology development. And you can see on this chart the types of decisions that are being made. At this year's architecture concept review, we actually debuted the first 7 of these key decisions that we intend to work on. And you can see them here, but some of the most important things are trying to think about science. What kind of science do we want to do? How many crew members do we need to send on the mission? How many crew members do you need on the surface? Making these kinds of decisions is critical to helping us design the architecture. So since that time, that the decision was made to study these 7 decisions, our teams have been performing trade studies to help our leadership make the most informed decisions that are possible. So I hope you've seen here, as I've been showing some of the slides, that our partnerships, particularly our international partnerships, are really key to the success of the Moon to Mars architecture and to human exploration in deep space. NASA is interested in international cooperation on every scale. We have partnerships that span from CubeSats to the gateway elements to pressurized crew rovers on the Moon, all the way with the purpose of furthering our Moon to Mars objectives. In fact, international collaboration is the #1 recurring tenet of NASA's Moon to Mars objectives. Because space exploration is such an immense undertaking, we can't do it alone. Today, there's multiple ways that international partners can cooperate with NASA as we return to the Moon and eventually travel on to Mars. Research, technology, development, partnering with US industry and academia, and the provision of elements or capabilities to the Moon to Mars architecture. Whether our destination is the Moon or Mars, we all explore for the benefit of all. In turn, we need all of humanity's support to realize this new campaign for crewed deep space exploration. If you're not already involved in the Moon to Mars architecture effort, I really want to encourage you to take a look at the links that are provided here on the screen. As I said, this is a pretty immense document. I'm wading through it myself, but I really encourage you all to take a look at it. This is the blueprint for our future. On the left-hand side, you're going to see a QR code there that'll take you to a website that hosts the current revision of all of the documents. You can find our architecture definition document there. You can also find an executive summary. Please start there. It's much less intimidating. And then all the white papers on relevant topics that have been produced so far. On the right, there's a QR code where you can go to our website and sign up to be on the subscription for email updates about the architecture events, including the next series of industry and international partner workshops that are going to be planned for February of 2025. And that's your opportunity to get involved and have your voice heard. So right now, I just want to thank you all for your time, and I really look forward to additional discussions. Thank you.